Right, we're going to do a quick run through this practice B graphs. Starting with the parabola, you need to have the name and the equation. Parabola. Our parabola starts, it's a negative parabola, and it starts at 0, 0. So this parabola has moved to the left 8 squares and down 2. So y equals x plus 8 in the brackets squared, because it's parabola, minus 2, it's gone down 2. Now it doesn't go 1 across, 1 down, 1 across, 3 down, so you need to find the a value. To find a, we find a point on the graph, so maybe I'll use this point here, which is -3, -12. So I substitute in that x and y value into my graph. So if I put -12 equals a -3 plus 8 squared minus 2, if you put that in your calculator, you'll get an a value. Remember, execute, execute. So that a comes out to -0.4. So the equation of the graph is y equals -0.4 x plus 8 squared minus 2. The domain is the values that are from here to here. So of the x's, that's from -13 x to -3 greater than equal to. Also, another feature of this graph is the line of symmetry. I'll put a squiggly line in. At x equals -8. There's a line of symmetry. There's also a maximum. You can give the top of the parabola, the coordinate point there, as a feature. Okay, our next look at the cubic. This S-shape graph, we've got y equals, now our first point here, it doesn't cut through the line at -10, it kind of bounces. So we're going to do, it almost looks like a parabola. That'll be x plus 10 squared, and my next point will be over here at 4, so it's going to be x minus 4. Again, you need to find the a value. I would find a good point, maybe the point 3, 3. You could put x is 3 and y is 3 and find an a value. The other thing with the cubic is our domain from -15 to 5 as the x values. The is the hyperbola. The hyperbola has 2 asymptotes. So if I look here, one asymptote is coming down at about x equals 3, and the other one at y equals 2, I think. So those are my asymptotes. X, so we can label those. Asymptote there. Now the asymptote has moved from 0, 0 in the center of the graph. It's moved to the right, it's translated right 3, and it's translated up 2. So normally a hyperbola is y equals a over x. So now it's y equals a over x to the right 3 and up 2. To find the a value, we need to look at the centre of our asymptotes and how far to, there's a point on the graph there. We've gone across 5 squares and up 2 squares. 5 times 2 is 10, so A equals 10. My graph is going to be y equals 10 over x minus 3 plus 2. Remember, x cannot equal 3. That graph gets closer and closer to x equals 3 here. This part of the graph gets closer and closer to x equals 3. So you must have that. When you're writing the domain, our domain is 3. We don't have an equal to x. X is greater than 3. It's not equal to 3, and it's less than or equal to 25. Okay, be careful of that one. The next is our exponent. The exponent is a growth graph. The graph, normally I'll draw it in green, comes along and it is slowly, think of bacteria growing, it goes up through y equals 1, and then it starts shooting up really fast. Think of bacteria growing. So that's what a normal graph looks like. You can see this graph has translated, it's gone, here's my point 1 here, so it's gone down 10 and across 6. Okay, so the graph is translated down 10 across right 6. So a normal exponent graph, an exponent like a growth, exponent is a growth graph, is y equals a to the x. Exponent means power. So now, because we've gone to the right 6, it's minus 6. And down 10 will be a big minus 10 on the end. The a value, remember, here's my asymptote coming along here at the bottom. I've got an asymptote there. It goes up 1 square. I look at the next bar and it goes up 3 squares. So my a value is 3. So the equation is 3x minus 6 minus 10. I've got an asymptote at y equals negative 10 here as well as a feature. And your domain is between 2 and 8. Okay, last is our absolute value graph, the pink one. If it was starting at 0, 0, it would start down here. So it's moved to the left 7. It's translated left 7 and up 10. I'm looking at the centre here. I'll do a big green circle. From the centre there at 0, 0 to the centre, the maximum on the pink graph, how far is that moved? Don't be looking at the edges. So my equation is y equals, now it's upside down, so it's negative absolute value x, and it's gone to the left 7, so that's plus 7, and it's gone up 10, so it's plus 10. And then my domain is between negative 10 and negative 4. Other features, it's got a maximum. You could give that maximum coordinate point. Negative 7, 10, negative 7, 10 is the maximum feature. It's also got a line of symmetry at x equals negative 7. I hope that's helped you with